Hello friends, this is sixth question of JEE Main 2015 physics paper code A. In the question, from a solid sphere, we have a solid sphere of mass m, radius r. A cube of maximum possible volume is cut. Okay, and we have to find moment of inertia of that cube about an axis passing through its center and perpendicular to one of its faces. Okay, so it's a solid sphere. Cube of maximum volume is cut. Okay, so what is the diameter of the cube? What is the diameter of a sphere? That is 2r. Okay, this radius is r, diameter is 2r, and from this sphere I am taking out a cube of maximum volume. Okay, so clearly the diagonally opposite points of the cube are actually located at a distance which is equal to the diameter of a sphere. Okay, so see, I have mentioned here in this figure, this is a, this length is a root 2, the diagonal of square, and this length is actually the diagonal of cube. Okay, that is equal to the radius, 2 times of radius of this sphere, the diameter. Okay, so I can relate 2 times of r, which is the diameter of a sphere, is equal to diagonal of a cube, which is a root 3. This type of question is very common in JEE problems. A square plate is taken out from a disk, or a cube is taken out from a solid sphere. So we have to relate the side of a cube with the radius of a sphere. Okay, so this is the relation. And suppose mass of this cube which is cut out from this solid sphere is m dash, and the mass of this solid sphere is m. So how can we relate these two masses, the solid sphere mass and the cube mass which is taken out from the solid sphere? We can say that density is same for both. So density of this full solid sphere, okay, when everything is solid here inside, so rho is equal to m upon 4 by 3 pi r cube, and for this cube m dash is equal to a cube. So m dash is a cube by r cube into 3m upon 4 pi. Okay, if we replace a in terms of r, so this will be a cube will be 8r cube by 3 root 3, 8r cube by 3 root 3, and this is 3m by 4r cube pi, 4r cube pi. So this r cube is cancelled, 3 cancelled. So now I am getting m dash is 8m by 4 pi, that is equal to 2m upon pi. This is the mass of cube. So mass of cube is 2 by pi times of mass of full solid sphere. Side of cube is 2r by root 3 from this relation. Now, how to determine moment of inertia of this cube about an axis passing through its center and perpendicular to one of the faces? Okay, so let me draw another figure. This is the axis passing through the center of the cube and perpendicular to faces. This is the axis. We have to find moment of inertia about this axis. Getting? So we can find moment of inertia of a cube about this axis using a concept of moment of inertia about a metallic square plate about an axis perpendicular to the plane of metallic plate and passing through the center. Okay, suppose this is the axis, okay, so clearly the side is a, suppose, so what is the moment of inertia about this axis? Using perpendicular axis theorem we can derive it. Suppose this is x axis, this is y axis, so ix plus iy is equal to I, which is the moment of inertia about an axis perpendicular to the plane and passing through the center. Ix and Iy both are equal and is equal to ma square by 12. So I can write ma square by 12 into 2 is equal to I. So this is ma square by 6. So this is our answer. Okay, because this cube can be considered as large number of metallic square plate kept one over another to form this cube. Okay, if you place similar plate over it so and keep on putting it, okay, so ultimately we get a cube. Okay, so mass of this cube is, suppose m dash, side is a, so we have a formula ma square by 6. So now let us write down its moment of inertia. So moment of inertia of the cube is m dash by 6 into a square. M dash is 2m by pi, 2m by pi. A square, from this relation a square is 4r square by 3, and this is divided by 6. So this is 4m r square upon 9 pi. This is our answer. Thank you.